two, 1 2 1 2 1 2 1 2. Woo!
Hello guys and welcome back to this one. Today we are going to be looking at the gate closest stars, right? We've already gone through the graphical illustration, we've gone through the brute force code explanation. So we are just here to see the code go through the debugger tool, basically the variables through the system, and we see where the waste is, and basically get more of like an understanding. Although I believe we have already done that in the code explanation and graphical, but this is like to make everything come together. So yeah, let's get into it. So we've set up our debugger tool and we're already inside the tool. So we instantiate our star distance. Sorry. So we are at our star distance, we instantiate that list, and then we go ahead, and then we can also watch on the left to see the variable changes. Let me zoom in a bit so that we have so yeah. So we, just as we said, we go through all the lists within the major list, and we get into the stars, the primary list. So yeah, so we can see here where we have 10 into the stars, the file. So we have 10, and then the distance is 100 for the first one, because it's 10, I think it's 1000. So these are the this is the question where we have 10. B has this 6 4. These are the coordinates. This is the star's name. This is the coordinate. This is the star name. This is the coordinates. So basically, it's creating that tuple within the the star. So we could see we could see the distance. Basically, this is what this function is doing. It's basically holding basically creating the distance and then appending the distance into the, what's it called? Yeah, into the star distances list. So let's continue. Okay, basically, it's going to match it. You don't want to match it, you just want to continue over it. Yep. So yeah, so star distances should just yeah, so it's created this guy as well. So let's watch it go through the entirety of the list and create their distances. So we are C now. C is passing in its values with its ID and then the distance. So it has a distance of 1. C comes in with another value, and it comes in so D now is now the guy on the point of contention. It comes in with its ID, and then it has 020 as its coordinates. So the distance is going to do its thing, and then give us back the distance of 4, right? Remember that we make it distance is just basically the square of everything added together. We did that on the intro of this series. So we continue. So we have 4, that is 555. That's 25 25 25. So yeah, we have that. Now we are done with getting the distance of all those files. So what do we then do now? We do a sort. Basically, when we sort now, we'll see how basically this stars and their distances is going to be sorted by this this key value, right, which is the distance value, and we'll then see how it's makes it become like according to the distances. So let's go through that. So you can see here start distance of sorts. So we don't have it, we don't hold it, so we can't generate. Okay, start distances, let's go deep again. So now start distances should be sorted when we get through this whole audio. Let's just continue. So sorting is doing stuff. Okay, so sorting is doing stuff, basically sorting the whole P. So it's good. We are basically seeing the sort process. Right now it's done. So when we look at our sort distance now, we could see C1D D4 25B. So we can see that it has sorted it according to the distance, right? That's what the sort guy does, right? Or the sort function does. Then we are going to see let's go down. So we could say we return the distance from from the 0 down to k. Now, what does that mean? Basically, we are taking from 0 down to k, whatever k is. So what did we bring in as k is the question. So we brought in 3, meaning we just want the first 3 stars. So it's going to be 1, 4, and 25. So let's step in. So basically, this is the final result where we see C1, D4, and B25, with all of them just, it is cutting out the one that we don't want, which is because we're looking for the first 3. So basically, that's what we are doing here. So we could see, again, just to speak of the complexity that we will get to in a short while, right? We could see the different complexities on the P. And yeah, not to allude to it, but yeah, next up we're going to be looking at the complexity, and we're going to now break down what's truly happening here, why this is a waste, and why we could even almost sense the waste even before getting to the optimization of this very function. So yeah, muchas gracias. See you on the next one. Bye.